So strengths and weaknesses of text analysis, we're doing kind of essentially what we did yesterday again today. We may try to do it a little quicker again. I'd love to hear all your experiences. If there's one that's very relevant, please jump in. Otherwise, let's try to at least make it through Brandon's stuff. I think he's going to show up around 10. So the first is qualitative detail or context. Does anybody recognize this picture? The sociologist. What?
The Balinese cockfight.
Yes, the Balinese cockfight. The legendary anthropologist Clifford Geertz writes a series of seminal papers about the contextual basis of meaning. Develops this like broad theory of thick description, meaning that most of the essential concepts in social science require a multi-perspective view. In this case, the cockfight is being interpreted in profoundly different ways by the men pictured here and by the anthropologist and so on and so forth, and it prompts this hermeneutic style of analysis that would come to permeate a lot of qualitative research in the social sciences, especially political science and sociology in the 1980s. So what's great about text? Well, it often has this detail. It doesn't have all the detail, right? Often the unspoken words are just as important as the spoken words, but it's at least probably better than surveys and other administrative record data and that kind of stuff. It's one real strength of text analysis. Second, it's big, it's abundant. This is just like digital trace data. Much of digital trace data is text data. If we're defining digital trace data as found data, right? So many of you, if not all of you, will be familiar with Google's massive project to digitize pretty much every book everywhere. And this is really a huge resource. There's many other similar efforts dating back often decades and centuries now. And of course, with some of the tools we talked about yesterday in terms of mining text from APIs or screen scraping, it's fairly straightforward to get large amounts of text now as well. And combining qualitative detail with size is unusual because historically, qualitative research required deep ethnographic work where one would go to a location and spend an extended amount of time, or a more hermeneutic style of analysis where a researcher does a deep reading of a text and becomes an expert by pouring into archives and understanding, some small set of observations, be they text, people, organizations, or whatever, but with a lot of detail. So this kind of breadth versus depth trade-off is something that we hope many of us who are interested in text analysis hope we can get at with these new data. We can have our cake and eat it too. We can get the qualitative detail with the depth. Again, we're not going to get as much as an ethnographer would get, but we're getting more than a survey researcher might. That's the bet. So there's a vast amount of this data that already exists. Yesterday, I encouraged you to ask yourselves whether you need to collect new data before you go out to collect data. And this link here is a crowdsourced list that I curate. We're actually going to use it in our group exercise today. You're going to choose one of these corpuses to analyze. And so is that me? Sorry. And if that's the case, so there's about 30 or 40 data sets on here now. If you know of any others or are willing to share some with the group, we can have even more to choose from for the group exercise. The group exercise today is going to be that you put your name on this spreadsheet next to a corpus that you want to work on. Not this particular Google Doc, but one that Taylor's going to circulate on Slack a little later. So if you're checking this out right now, you'll see there's just a ton of different data sets out there. The New York Times has a large annotated corpus, Reuters, Google, Wikipedia, and there's many, many others. Google Ngrams that you can get through Amazon Web Services. Third, we mentioned yesterday the strength of digital trace data is that it's non-reactive. Same thing with text data. Most text data is not produced with the understanding that a researcher is going to study it. That said, lots of texts are produced in public settings where they have certain goals. So yesterday, I think it was Maddie who mentioned that, to what extent is political to what extent are political statements more likely to express in one setting than another? We talked about positivity bias, so it's not everything, it's not the perfect data, but once again, we get these pretty interesting non-reactive data sets, meaning that the data do not result from an intervention by the researcher, and they're therefore possibly more true to life or naturally occurring. So here's an example of from Stevens Davidowitz of the racist Google searches using keywords for derogatory terms for African Americans. Another cool thing about text data is that it opens up an entire new line of inquiry, I think. Laswell, of course, was trying to study propaganda. He was trying to study how ideas persuade, how ideologies diffuse across groups of people. But that research agenda has kind of dropped off in many different fields. It's roaring back now in the last decade. Pretty much everyone in every field is having some type of discussion about the role of ideas or culture, in my view, whether it's how to create a culture that addresses our obesity epidemic, or how to win the battle of hearts and minds in the fight against violent extremism, right? And we could go on and on about many different examples, whether political polarization results from ideas and ideology or underlying interests, right? It seems more and more everywhere we look, there's a battle of ideas that social scientists need to understand. And so text data is great for that. We can really measure, once again, both the prevalence and the flow and diffusion of ideas, and more broadly of meaning, which is something that is notoriously difficult to measure. And many of the techniques we're going to talk about today, I hope are going to take us in a first step towards measuring meaning and measuring things like ideology. Any other strengths people want to throw out there? No? Yeah, Rochelle.
Kind of dovetails on a lot of things that you mentioned, but just to make it explicit, is that it's inexpensive in terms of time.
Uh-huh.
It can scale well.
That's true. Yeah, that's a great point. Yeah.
So even if tasks that you would otherwise not need a computer for, hand labeling text or whatever.
Sure.
It could just, I learned computational text analysis because I was lazy and didn't want to hand code a bunch of articles, and I thought a computer could do it faster.
Yeah. Yeah, great point. Other points? So on to the weaknesses. So yeah, on the one hand, it scales well. On the other hand, there's all sorts of new challenges. If you're used to working with neat square or rectangular data frames where each row and cell has a number in it, text data is unwieldy. So for example, here's a newspaper clipping that's an interview with Trump. And I just want to note a few things about this text. First of all, we've got two people talking, the interviewer and the president. We've got, I think by my count, about 5 or 6 different subjects in here. He's talking about Egypt, he's talking about Obama, the AP interviewer is talking about other things. And, to change this text into some classification, 0, 1, this theme does or does not exist, right, is an enormous challenge even for a human coder. And putting this type of multivocal, polysemic text into neat numbers is pretty tricky. And there's a lot of pre-processing steps that we're going to talk about today, things like whether you care about word capitalization or word order. These all turned out to have big effects on the types of patterns you find often. And so we're going to talk about how we clean up text data. That's going to be one of the subjects we're going to cover in the next section. Okay, so although maybe these texts are non-reactive and that's good, history is written by the victors, right? There's a publication bias. There's an elite bias. You know, if we're doing a study of research and research trends and what scientists are doing, for example, we're missing, you know, some huge amount of the results that are never published. We've all heard these stories about the file drawer where papers are put. But we could talk more broadly about how, you know, everyday people usually aren't producing the texts that get analyzed in text analysis, right? There's some exceptions. There's some interesting efforts, the Mass Observation Archive in Britain, for example, to do a kind of major large-scale oral history. There's an oral history library at Columbia that has some interesting data sets as well. But by and large, especially historical data, we're dealing with an elite bias. Whether that carries into social media text today is another question, and one that I think the jury's still out on. We saw some of those figures yesterday that show that the demographics of who's using what platform are very different. So maybe some platforms are more prone to elite bias than others. Like maybe Twitter is more prone to elite bias because people only use it to brag about stuff. Who knows? Third, we have this very vexing issue of polysemy, or the tendency for text to have multiple meanings, and also hidden meanings. So, you know, this is the classic Magritte pipe, right? Is this a pipe? Is it not a pipe? Right? That's the thought experiment. It's meant to convey the many ways, just like the urinal that Matt showed on the first day, that, you know, texts mean different things to different people. So that's a huge challenge. Capturing the meaning of a text itself is hard. Capturing multiple meanings to multiple people is even harder. We talked a little bit yesterday or Gary talked a little bit yesterday about his anchoring vignettes and gave that example of running in sub-Saharan Africa and how it had this profoundly different meaning than it does here, right? So it's really tough to understand the context that might shape how different people reading a text might interpret it, particularly if you're out to understand how ideas flow. And second, and maybe even more vexing, is the texts that aren't produced, right? The things that are not said. There's vast literatures in sociology, psychology, political science that document the power of framing. You know, for example, how language is used to focus on one thing and not another. But this raises a really vexing question about if we count the frequency of words and the absence of certain words, is that really capturing the hidden meaning? Is that really capturing the unspoken elements of text, or things like the tonality of text that might be used to detect, say, sarcasm or something like that? These are all really, really hard to find in natural language. Let's see, limits of measurement. So, you know, we do still have limits. You know, for example, you know, we're trying to figure out here what computational social science means on this Reddit here. We have these same two problems. We have the multivocal problem. So we have multiple people saying multiple different things about multiple different fields. There's a real point, you know, we have computational limits. Those are eroding quickly because of computing power, right? But some texts, I think, are just beyond measuring objectively. And so texts like a press release where one person has one point of view that they're expressing to one audience, that's a much easier text to study than something like a Reddit, I think. Though if you're interested, I think Reddit is one of the text data sets that's up on the crowdsource list there. Non-findings. I think this is a really big one. So on the one hand, like Rochelle, I appreciate that I don't have to read everything. On the other hand, to some degree, I rely upon an algorithm to tell me what's important about a text. The data scientist at Facebook, Jonathan Chang, has likened this to reading tea leaves. So, you know, we run our automated analysis, we get a result, and there's something interesting about it or intuitive, and so then we start, you know, making a big deal about it. But what if it's not a thing? You know, what if it's an artifact of a strange character that was appearing in text and due to some HTML tag error, one of the types of those strange tags in text that we saw in some of the JSON data that we looked at yesterday, HTML data that we looked at yesterday, right? That's a real danger in this field. It's even hard often, as we'll see, to know how many themes you're looking for. And often we don't have strong priors about how many themes we're going to find in a text. For example, if I asked, how many themes do you think we'd find in that Reddit about what is computational social science? Any guesses?
0.
It's unknowable, right? I mean, can anybody even hazard a guess? And yet, if we're going to train a model to do that, we probably should have some inkling of an idea, rather than running every value from 0 to 1200. That's one way, and that might get us started. Then we might start reading and segmenting, and we'll talk a little bit about topic model validation and model validation. But the danger of reading tea leaves is really significant in text analysis. Any other weaknesses of text analysis, personal experiences people want to share? Yeah, Ethan, yeah.
Question. It seems that the non-reactive strength is also a weakness, right? In the sense that it can be hard to make sense of those Google search results substantively.
Yeah.
Right?
Yeah.
Just want to write some program.
I think so, yeah. Yeah. I think it's a context dependent, which corpus or data or text-based data set you're looking at. But yeah, I agree. Yeah. Any other weaknesses I've missed or other experiences those who've done automated text analysis have to share? Charlotte, yeah.
This might come later, but is there a lot of stuff where people do a traditional sort of content analysis, like you pick a sample, like maybe 50 things that you can read, and you come up with some theories, and then you sort of test for the prevalence of the topics that you identify in the data. Is that a common approach?
Yeah. I think so, and I think so because the last time I saw David Blay, I was asking him about this validation problem. I was saying, how are you dealing with this? And he said, well, when we were building it, we never thought of it as a way of producing data. We thought of it as a tool for reading. We thought of it as a way as focusing a microscope, zooming back and forth in a text to intelligently approach a large corpus. So it's interesting the way it's been employed, right, has been to measure things, right, to say, here's my topic model, here's the 10 things that matter about this text. One of these things relates to my theory, and so then I'm going to put it in a regression model and go for there, right? And he's very concerned about reckless use of topic modeling. Also, David Mimno, one of the early pioneers, has a lot of, he's written papers with, for example, sociologist Paul DiMaggio, John Moore, Robin Wagner-Pacifici, and Ronald Bragger have a really interesting paper combining qualitative and quantitative folks to approach a corpus and applying the literary theory of Kenneth Burke in really interesting ways to the national security documents over a century. And John Moore in particular, who again was one of the early proponents of quantitative text analysis in sociology, is a big fan of this back and forth, sampling, the strategy you just described, taking some sample, understanding it, thinking about what the model might find. Of course, it's a time-consuming process, right? On the one hand, we do this stuff so we don't have to read, but often we find ourselves still reading a lot, or you should find yourself reading a lot. Good, yeah, good point.